Welcome! Today we are diving into the fascinating world of fractals. Fractals are self-similar patterns that display infinite complexity within a finite space. From Mandelbrot sets to coastlines, fractals are all around us. Let's explore what makes them so unique. So, what exactly is a fractal? A fractal is a geometric shape that shows self-similarity at all scales and has a fractional dimension. Some of the key characteristics of fractals include detailed structure at every magnification level, recursive patterns, and infinite complexity. A classical example of a fractal is the Koch snowflake. Self-similarity is a fundamental property of fractals. Each part of a fractal contains a reduced-size copy of the entire structure. Therefore, if you zoom into any section of a fractal, you will see the same pattern repeating at smaller scales, potentially infinitely. A well-known example of a self-similar fractal is the Sierpinski triangle. One of the most famous examples of fractals is the Mandelbrot set. This fractal is defined by the iterative formula z subscript n plus 1 equals z subscript n squared plus c. Points that remain bounded under infinite iterations form the intricate boundary of the Mandelbrot set. The boundary displays endless complexity and detail, no matter how far you zoom in. Unlike shapes in traditional geometry, fractals possess non-integer dimensions. The fractal dimension measures how a fractal fills space as you zoom in, revealing its complexity. For example, the Koch curve has a dimension of approximately 1.26, the Sierpinski triangle has a dimension of approximately 1.58, the coastline of Britain has a dimension of approximately 1.25, and the Mandelbrot boundary has a dimension of 2.0. Fractals are not just mathematical constructs, they also appear in nature. Coastlines, for example, exhibit fractal properties. This means that the more closely you measure a coastline, the longer it becomes. This phenomenon is known as the Richardson effect, which illustrates how natural boundaries display infinite detail at smaller scales. This leads to the question of how long is the coast of Britain? The answer actually depends on the length of your measuring stick. Fractals can be generated using simple recursive algorithms. These algorithms, though basic, can create infinitely complex patterns. The beauty of fractal generation lies in how mathematical rules generate intricate, natural-looking structures. The slide shows a basic code snippet that can be used to generate a Mandelbrot set. Fractals have a wide array of applications across various fields. In science and technology, fractals are used in computer graphics and animation, antenna design optimization, data compression algorithms, and medical imaging analysis. In nature and biology, fractals help in modeling plant growth patterns, analyzing blood vessel networks, studying lung structure, and understanding ecosystem dynamics. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.